Hello, npage. So this is my response. I'm sorry it's really late, but I've been busy for the past month. But in any case, here it is. In my last video, I wasn't trying to strawman your argument. I was just paraphrasing your words. But in any case, I think it's still my argument still applies to your the actual words you used, and I hope to clarify that in this. And also, if I'm misstating something, just tell me. So in response to your argument, I'm going to go about this in two ways. First, I want to talk about the flaws in your argument. Secondly, I want to formulate my argument about the brain and the mind. So first, there seems to be some confusion about the word causation. You say that with the keyboard example, that the keyboard does not directly cause the words on the screen. That's true. You also say that one-to-one correlation does not mean causation, and this is true as well, but that's not what I'm arguing. All I'm saying is this, that the keyboard is required for the letters to form on the screen, not that this is directly causing it. So to prove this point, if you remove the keyboard, the letters will not form no matter how hard you click on the mouse or anything else. But the keyboard is not the only thing that's required. If you keep the mouse but cut the cable connecting the keyboard and the computer, no matter how hard you bang on the keyboard, the letters will not form. So the cable is also required. So this is actually the process of experimentation. In science, we find out what is required by removing it and seeing what happens to the system as a whole. And this is what I do in my research lab, where I remove genes and see what happens to the animal, right? At least have mutations in the genes and see what happens to the animal. So to clarify my argument, I'm going to replace the word it causes with it is required for, because this is sufficient for my argument. It doesn't need to cause it, it just simply needs to be required for it. Because if you remove it, then it cannot function. So that's enough for me. So also, I thought it was ironic in your response. You say that the only thing my argument shows is a correlation, because this is what I argued that you do with your first premise. You say that if something is impossible to imagine, then it cannot exist. And you show the example of the squared circles as evidence of this to show that it supports your premise. But it actually doesn't. All it shows is a one-to-one correlation, and this is why. It's because I can think of a valid explanation for why squared circles don't exist without invoking our ability to imagine it. So I can talk about the properties of a square and a circle. The properties of a square is that it has 4 sides. The property of a circle is that it has 0 sides. Since 4 can never equal 0, a squared circle can never exist. I never mentioned how whatever imagining has to do with it. So that's why your example is equally likely to support the converse of your premise, which is that it cannot exist. If it cannot exist, then it is impossible to imagine. And it can also support other premises. If squared circles cannot exist, then it is impossible to breathe in outer space. Just as I have not shown you how the non-existence of squared circles is required for my inability to breathe in outer space, you have not shown how the inability to imagine squared circles is required for them not to exist. Until you do this, all you're showing is a correlation between the two, and not an explanation for one or the other. In any case, I have an example which invalidates your first premise, which is the one I talked about before, but I'm going to make it clearer here, and I'm going to use the keyboard as an analogy to make it easier. So as we've shown with the keyboard, we can say the function of a keyboard is required for the letters on the screen to appear, correct? Because if you remove the keyboard, you can't do anything else, and you can do anything else, and the letters won't appear. Thus, if the keyboard is not functional, the letters won't appear, right? This is the conclusion we can reach. So with my example, we can say the function of the brain is required for the function of the mind. Thus, if the brain does not function, the mind does not function. Now, all I need to do is prove the function of the brain is required for the function of the mind, which is an extremely simple task. In any case, other people have already done it. So all you need to do is read the papers that I posted last time, and I'm going to post them again in my description box, but I'm not sure if you have access to them because they cost money and you have to be a student to access it for free. So I'm just going to quote it for you, the important parts here. So this is from the paper Probabilistic Reasoning by Neurons. And it says, as with any research paper, what they do is they look at what other people have found, and they use that as a basis for what they do in this paper. So in their introduction, they say, quote, "It has been demonstrated that when the outcome of a decision is an eye movement, a neural correlate of the evolving decision can be recorded in brain areas associated with higher motor planning and attention allocation." So other people have found simply a correlate. Quote, the mechanism mimics statistical decision processes that accrue evidence sequentially in the form of a log likelihood ratio that favors one outcome over another, end quote. So the mechanism they have found is that it mimics only log likelihood ratio. Now, quote, therefore, it has been hypothesized that a neuronal substrate of probability integration exists in area LIP. Other people, end quote, other people have hypothesized this. Quote, to test this hypothesis, we blah, 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 blah. So obviously this hypothesis is the crux of their paper. It's extremely important. So let's look at it much more closely. Therefore, quote, therefore it has been hypothesized that a neuronal substrate of probability integration exists in area LIP. Remember, a neuronal substrate is an area of the brain made up of neurons. Thus, it is a property of the brain. Probability integration is required for decision making. Thus, this is a property of the mind. So what they're doing, in their own words, is to make a connection between the brain and the mind, and that one is required for the other because that area exists for integration to happen. It's required for integration. So also, you are right. It's not enough to find correlations in science because those people who've done it in the introduction didn't get published in Nature, which is one of the best journals in the scientific community. But these guys did, so they showed that it's more than just a correlation. And I'm going to quote the exact phrases that show that this is indeed the case. So, quote, indeed, it has been suggested that the buildup of activity in the brain associated with a wide variety of simple decisions is an approximation of the summation of logarithms of probabilities, likelihoods, odds, and so on. The present findings provide direct confirmation of these theoretical insights for the first time. The others have not done this. This is the first time. They demonstrate directly that the firing rates of LIP neurons are proportional to the log likelihood ratio conferred by the shape stimuli in our task. So direct confirmation. Quote, the present study exposes the brain's capacity to extract probabilistic information in a set of symbols and to combine this information over time. Thus, we have demonstrated a crude capacity of probabilistic inference in monkeys, end quote. Remember, probabilistic inference is a property of the mind, and they have demonstrated that by looking at neurons. So, to put this logically, let me show you what they said. The function of the neurons in the LIP, it's an area of the brain, is required for probabilistic inference to occur. And probabilistic inference is required for decision-making to occur because they fire at a proportion of log likelihood ratio. Now note that they did not say that the neurons directly make the decision. The keyboard doesn't directly put the letter there, right? The neurons don't directly make the decision. In fact, they say in their paper that they're not sure if it actually does the transformation or is just if it's just accumulating the information from other neurons. But that's not necessary for my argument. It's simply necessary that it's required, that that area exists, and this is where integration happens. Just as the keyboard is required for the letters to form, this area of the brain is required for decision-making to occur. So let's say that this brain dies, right? And the area of the brain disintegrates. Then we can conclude that decision-making has stopped. It ceases. So can you imagine a state of non-decision making? Such a state is impossible to imagine even logically, because by attempting to imagine a state of non-decision making, you're making a decision to imagine it. So yet we know that such a state must exist based on the conclusions of this research paper. So I have provided an example of something that is impossible to imagine but which exists, which is a state of non-decision making. And this contradicts your first premise. And therefore, it follows that your conclusions from the premise must also not be true. Now, the only real argument that I can think of against this is that science can never prove anything 100%. And this is true. But that's why experimental science doesn't prove anything. Mathematics does. Theorems based on mathematical equations. But by the same reasoning, you shouldn't take penicillin if you're afflicted with syphilis, because science doesn't prove that either.